YouTube. All right, I think I'm live now. Okay. Looks live. Let's send a link to everybody, I guess. So I'm not sure how to do exactly. Okay. All right. Oh, Joel, hello. Hi, everybody. Welcome to my channel. Happy Friday. Woo, woo. Oh, I don't. Okay. I'm going to switch back over to OBS because it seems a little bit more like real time. Ah. Oh, hi, Taylor. Hi, Joel. Yes, I'm going to be at RubyConf in person. Yes. Yes. Oh, hey. What? I gotta do. Sorry, I can't, like. How do I make this thing wider? Okay, gotta put these up 10 minutes early so we can. Really? So I'm. Thank you, Jeremy, for the pro tip. I don't know anything about streaming at all, so I will do this. Okay. Let's see. So today I'm gonna be doing some hacking on TenderJIT and oh, Justin. Yay! IRL RubyConf. I'm so excited. Um all right, today I'm gonna do hacking on TenderJIT, and I made like a few slides. So I'm just gonna go through what I'm doing, what I want to do today, and I mean I don't know how much of it we'll get to, but let's like I just came up with some ideas. So and how do I gotta bring up Keynote. All right. So the first thing I want to do is like I haven't made TenderJIT work with OptCarrot yet, or like it's not working. I want to get so the first thing I want to do today is get TenderJIT working with OptCarrot. I think we've implemented enough instructions that it'll mostly work, and there's one error, and we're going to try and fix that, and hopefully it'll all work. But we'll see. And if we can get through OptCarrot, then I want to do something like I'm calling pass parameter types. I don't know. Oh, hello. Thank you. I'm happy to stream. And this is only the second time I've streamed, so like if anybody has pro tips for me, please let me know. I would like to do this. Well, I'd like to continue doing this, but make it a better experience for everybody. Anyway, so I want to start passing parameter types around, and what I mean is like, so right now, TenderJIT will do code specialization. So for example, if the JIT compiler sees this code, like it's smart enough to know that we have, from the instructions, it can tell, oh, we have an int literal, like the int literal 1, and it can tell that we also have the int literal 2. And when we compile when the JIT compiler compiles the opt plus instruction, it knows to emit specialized code. So it knows that the code should be specialized for integer addition. So when I say like passing types, what I mean is like if you say you have this code here, where like we're still doing a plus, but you're passing parameters to another function, like it loses the types. So down here, the caller has like put two literals, but the callee is just saying like get the local. So when the JIT compiler compiles like get local, it loses the type. Like it doesn't know what type it is. So I'm hoping if we can get through optcarrot, then I want to try teaching the JIT compiler how to identify what types are passed in as parameters. And yeah, so this opt plus, like in this case, the JIT will compile this opt plus as like a generic call to plus, and when we'd really like to have a specialized call to plus. Also, I mean, we're probably not going to get to this today, but I want to be able to have like multiple versions of methods. So like, for example, in this case, like maybe at this call site, we'll have it'll call into a specialized version of add ints that's specialized for integer addition, for example. And then in this one, like maybe it'll be specialized for string concatenation. So I want to do that eventually, but it's like it's not set up for that. And I mean, maybe we can start hacking that today, but I doubt it. The passing types into methods sounds like it'll be a project. So, all right, I guess that's it for that. Let's do. Oh, there we go. No hands. I don't know. Let's quit Keynote. Goodbye, Keynote. All right. So let's see. So I got a branch checked out here. Oh yeah, and if anybody has questions while I'm hacking on this stuff, throw it in the chat and I will read it and answer. And this is so I've got TenderJIT here and I've got optcarrot checked out here. And I have this in my history, optcarrot. I think. Yeah. Oh, BE, Ruby, bin, optcarrot. Examples, landmaster .nes. Okay. Oh, neat. All right, try this. And while this goes, we'll have a message from, I guess it was fast. Okay. Oh, NES. That probably helps. Watch me fail in real... What? Come on. Land underscore master, of course. Okay. So if I get the file right, maybe we can run this. Okay. And hopefully, yeah, I'm not using the debug version. That is good. Otherwise it'd be very slow. Yes, JIT checkout, TenderJIT. So right now, TenderJIT doesn't compile things automatically. We have to like tell it, hey, please go compile this method. And I mean, clearly that's not good for JIT. In the future, I'll fix that. We'll do that in a future live stream. But for now, we have to say like, hey, please compile this thing. So I'm going to change this bin file. Let's go. And I know the font on this is small. I'm going to bump it up here in a second. Woo! Yay! Seems big enough. Is this... There we go. Look at that. Nice and big. All right. So let's do require TenderJIT. And we have to... Oh, I wanted to show off. I got the, like... Where is it? I got the mini... Like a mini keyboard. Woo! So I can copy and paste. They need to do this. They need to do this for... They need to make a keyboard like this, but for Visual VS Code to do the, like, what is it? Their suggestions things. Okay, Stephanie has a question. How are you choosing which instructions to add first? It's a great question. So, the way that I do it is, like right now it's been mostly kind of random. I just like pick which ones are easy. So we read the instruction code in Ruby and then pick easy ones and do it. But now what I want to do is like compile optcarrot and run optcarrot and then check the check what instructions aren't supported. So TenderJIT will keep track of the instructions it can't run, and then we can output the ones it can't run, and we can implement those. Okay. Let's see. Oh. I keep my fonts pretty small, I guess. All right, so we've required TenderJIT. Let's create a new JIT. Equals TenderJIT.new. JIT.compile. So we're going to compile opt. It looks like I'm going to compile the run instance method, I think. Because that looks like our main one. Opt nes.instance method run. And then another thing is like you have to enable the JIT specifically. So we'll do that. Okay. So enable it, disable it. And I believe, so I'm going to go back over into TenderJIT. We have to run, like I got to run it from a path or from the checkout. So let's do, I also think I have this in my history. Yeah. By the way, this BE here, I have bundle exec aliased to BE. So if you see BE, that's just bundle exec. And let's see. So if we run this, it will not work because I'm in the TenderJIT directory. Okay, let's find the right one. Come on. There we go. And let's make this command a little smaller. BE -v. We'll not do -v. Okay, so we're going to run opt-caret. I'm currently in the TenderJIT directory. We'll run opt-caret and we'll run the landmaster nes. And yes, it raises an exception. And the exception is inside of TenderJIT in the runtime. So let's go, let's go take a look at maybe it's here. No, not in the runtime. IC compiler 831. So let's go look at that. Let's do LCD JIT, and we'll do fin IC compiler. And what line was that? 831. 831. That's why it raised an exception. Oh, can I do? All right, so it raised an exception because I just put a raise in here. I think the reason I put a raise in here is because I didn't have any tests for it, and I knew we should probably write a test. Yes, Tiago, raises. It did the right thing. All right, so let's fix this. What is this? What the heck is this? It is opt aset. Okay. So we're calling compile opt aset, and that comes from handle opt aset. So if you've been in previous, previously I showed, basically we go through each of the JIT compiler goes through each instruction and it calls a handler method for each instruction, and that's this handle method is the opt aset method. So we could write we should be able to write a test for this. Let's do test.rb. Looks like I was writing other stuff. Yeah. Split screen's kind of small with this font so big. We'll just make it one screen. Okay, so let's do a set. So we'll take an array and some value, I guess, and then do A1 equals B. I don't know. Let's do that. And actually, let's just print out the instructions for this thing and see what it is. We'll do ruby --dump equals insns test.rb pop set. And yeah, okay, so here's our a set. That's the instruction that we're dealing with now. So let's let's get rid of this. We'll call just do a set. And then I think, like right now you can pass in a hash and it should work. Because I think the hash case works. Ah, yes. So, who asked this? Stephanie asked, how do we find which ones to work on? And this exit stats thing right here. So this is how we keep track, like TenderJIT keeps track of all the instructions it couldn't compile, and we can access those from Ruby, which is right here. So actually I'm gonna add this line over into opt_caret so we can see, like if we exit, we'll know what instruction we exited on. Let's see. So we'll do this. And I believe, let's do be -I lib test. Let's do this. Oh, probably help if I require it, huh? Okay, let's run it. All right, so we didn't exit on anything and it worked. So great. But I think the case that we're looking for is arrays. So if we pass in an array, yeah. Okay. So this is the same exception. So let's pull up test instructions opt aset test. Oh boy. Let's just copy this method. Not used to working with a font this big. Aset array. Oh, it looks like, yes, someone was kind enough to write tests for this, but we have skips. We have skips in them. Okay. Okay, so I don't need to write a test. That's very nice. Let's check out this array, or check out this method. I think this one, and they put this is so nice. Thank you to, let's look. Yes. Thank you. I don't want to butcher their name, but thank you. Okay, so this is it, and it calls opt aset, and this is exactly what we want. Okay, so let's do this. Run the test. Test instructions. What was this? Opt aset test. So hopefully this raises an exception. It does. Great. Okay, so let's fix it. Okay, so when handle opt aset is called, it generates a stub. So like, or a deferred compilation task essentially. So when we execute this, like, I think I showed this last time, but I'm going to show it off again because I just think it's very cool. Let's do test.rb. We'll change this back to a hash so it doesn't, like, we can see it in action. So it generates a stub right here, like essentially it defers compilation of this instruction. And the reason we want to defer compilation of the instruction is because, like, we don't have any information about the method. So, like, if we were just looking at this method without executing it, like if we just looked at this aset method, we have no idea what type A is or B is. So how do we know, what method we need to look up, or what kind of, like, how do we know to compile this, or how can we compile this? So what the JIT does is it says, okay, well, I know that you asked me to compile an opt aset, but I don't know what type it is. I don't know what type you're going to pass in. So instead, what I'm going to do is I'm going to add a jump instruction here. And when this jump instruction executes, we're going to pause the program and check out what value was passed in or what value we're popping off the stack. So in this case, we have essentially a deferred compiler entry, and this deferred compiler calls back into Ruby. So we pause the execution of the actual program and then re-enter the JIT compiler, and that calls this opt-aset method. And this opt-aset method takes a look at the stack, and it's able to figure out what object came from the stack, and then that's how it figures out what should be, like, how we compile, and it mutates the assembly code here. So this jump instruction changes. So like if I put a breakpoint here, and I really need to clean this up because we're writing. I know it's Ruby. I know it's pure Ruby, but this is really assembly, so I'm sorry. So we'll put a breakpoint here, breakpoint. And back here, so after the deferred compiler executes, let's add another breakpoint. So we'll do breakpoint here, rt.break. And if we run the test script, if we run this with LLDB, so we'll run it. Now we hit that first breakpoint, and you can see the jump address here. And what is there? There's like a disassemble. Yes, we want this, but not those parameters. We'll do start address. We're going to check this start address here, 1078. So there's that jump, the same one here. Now I'm going to hit continue, and it's going to enter the deferred compiler, and we're going to break again when the deferred compiler returns. So if we say continue, so we hit another breakpoint, and if I disassemble from here, I think we can do -C5 maybe. This should give us 5 instructions. Yep. Yeah, okay, great. So you can see the jump address changed. So it's the same, the memory location is the same, so 44078, 44078, but the previous jump instruction was to here, which is our deferred compiler, and now it's to here, because we've figured out the machine code we want to generate. We generate the machine code in a different location, and now future calls will just jump into that new generated location. Okay, so that is how that works. Unfortunately, it doesn't work with arrays, so let's figure that out. Let's look here, back in here. Okay. So we have arrays here, and basically what we're doing is we're just going to say like RB array store. And the reason I chose RB array store, the reason this is in here, is if we take a look at the original instructions. So if we edit ruby get ruby insns.def, so we want to look for opt-aset, because that is the one that we're implementing. So here's opt-aset. And if we read this, so opt-aset calls into VM opt-aset, and if we go check out VM opt-aset, why is this? My C tags are not found. If we go into opt-aset, we'll see here, it's like, oh, if this is an array, wish I could like draw with my mouse. If this is an array, we're going to call RB array store. So that is why over on this side, we say, okay, RB array store right here. Okay, so back over here, what does RB array store take? RB array store takes the receiver, so that should be the array, the index of the array here, and then whatever thing that we're going to set in that. So we need to pop those things off of the stack. So we say like, okay, actually I've already popped them off because we have to do this for hashes too. Because we say down here like, oh, okay, hashes does this thing. Actually, this should be, this is very nice. This should be exactly the same as hashes. That is good. Okay. So I think we can just put this here and then change the function. Store. Okay. Cool. Yeah, so when this deferred compiler executes, we take a look at, like, we're able to peek at what's on the stack at runtime. So we can say like, oh, what has been pushed onto the stack? Is everyone hearing my cat purr? We can see what is pushed onto the stack at runtime. But the thing is, when we check the stack at runtime, we just get the addresses of the objects. We don't get the actual object itself. You just get an integer that is the memory location of the object. Now we can do a fun trick. I don't know why I put that in quotes. I guess I put it in quotes because it's very, very dangerous. You shouldn't. I mean, I was gonna say don't try this at home, but do try this at home. It doesn't matter. Like if your program crashes, like it's just your computer, right? It's fine. Anyway, we can say like we can ask fiddle. So if you do this fiddle.dl unwrap, it'll take an address and it'll give you back the Ruby object that's stored at that particular address. So this is essentially lifting the class up from memory into actual Ruby land. So when we say DL unwrap right here, we actually have the class's address. So convert, like I should put a comment here that's like, convert the class address into the actual class object. So we can see what the actual class object is, right? All right, so we'll do this. I think we fixed this. Let's give it a whirl, see if the test pass, or how badly it breaks, I guess. Nothing ran. Why did nothing run? Let's see. Why did nothing run? Okay, bu. Actually, can we run like -v? Oh, are we like exiting or something? That is quite odd. Oh, I wonder. Okay, let's get diff. Ah, yeah, I left this breakpoint here. Don't do that. Question: can we turn this address into the value? Yep. Yeah. Totally. Okay, so yeah, we need to get rid of that breakpoint. So let's do that. Oh, I want to do this. Let's see. I can't tell. It's very hard for me to use this in such a big font. All right. Where did it go? Is this the right one? Int. Let's just look for it. Well, actually, no, I should be able to do this. There we go. All right. Now let's try it. Make sure we only have the changes we want. Okay. Hey, it passed. Great. And actually, while we're here, let's take a look at that other test. A set test. Because I think there was a skip. I think there was a skip in that one. Please implement opt aset for hashes. I think hashes are already implemented. Raise works as expected, so do breakpoints. Yes. I think this is implemented, so let's try. So we're saying the assertion is essentially like make sure that we compile a method. We don't have any executed methods, so TenderJIT will keep track of the number of methods we compiled, the number of methods we executed, and the number of exits and what those exits were. So we're just asserting that we haven't done anything. We enable it, call it, and then assert that indeed we stayed with one method and we were able to execute the method and there were no exits. So let's try it. I think we can just run this. Yep, nice. Okay. Cool. I think there's another test case that we should probably add. But I don't really want to do it right now. No, we'll add the test, but I don't want to fix it. I don't want to fix it right now. Because you can do like, let's pull up test.rb again. My favorite file here. So we're emitting specialized code. Like if you look at the compiler, I don't think we need opt-caret anymore. Let's go back to the instruction sequence compiler. If you look at this, we're emitting specialized code depending on if it's an array or a hash, right? So this like the machine code that we emit is specialized based on the type that we saw at runtime. Unfortunately, we currently only handle arrays and hashes, and we could pass like an object to this thing. So we could do like, I don't know, what's something that's not an array or hash that also responds? I think struct. Can you do like struct.new foo? I think you can do like this. I'll just leave that. I think you can do this. Yeah, you can. Okay, cool. So let's just do that. So we'll do struct.new. Oh, we're not gonna. Can you aset on a struct? I don't know. I guess it doesn't matter. Just do foo, and then .new. Just be like obj equals. So if we pass this in, we're gonna get an exception, and unfortunately, the exception is gonna come out of the JIT compiler, which is not. I don't know about all of you, but I would be quite surprised if my JIT compiler was raising exceptions in production. You're like, oh, we're getting these exceptions. We'll fix it in our code. Oh, wait, no, the exceptions are coming from the JIT compiler. No. And yes, I'm totally suggesting that you run TenderJIT in production. Okay. So let's run the test. Let's just do test.rb. And if we run it, yeah, right here. See, we get the not implemented error. It's not implemented. So we need a test, like, we need a test for this case. And if any of you want to send a pull request with a test for this case, please do it. Okay. So let's run, we implemented that case. Right. Our goal was to run opt-caret, and we implemented the case that was breaking an opt-caret. So let's try opt-caret again. Here we go. Nice. So yeah, it ran opt-caret. It ran opt-caret, and it exited once on get constant. And actually, this isn't bad. 45 frames per second. What were we seeing? So with regular Ruby, what were we seeing? Thought I had it here. 37 frames per second. Hey, so we got. Hey, that's kind of cool. Of course, this isn't a scientific experiment. Let's run it again. I'm sure it's going to be slower. Please. Oh, no. Look at this. It's totally broken. 4096. There's no way this is working. So checksum. Yeah. Oh god, awesome. So it's running and there's no exceptions, but it's got the wrong checksum. So actually, you know what we should do? Well, why would it do that? I would expect to see like an error or something. Huh. All right. I don't know. Let's see. Let's see. You could add TenderJIT in production. Yes. Totally chaos engineering. Yes. We could. Okay. Let's run this with, yeah, I have no idea why this is not working. So we should probably figure that out. Let's see. RB Aries store. Is RB Aries store working? properly? I mean, probably. Let's check. What is the param? Oh, this should be right. Okay. I don't know. Let's run optcarrot with debugging on. So I added a thing to TenderJIT that if you run Ruby with debugging enabled, it'll show you all of the instructions it's executing. So maybe we can find an issue here. Wow. Running a lot of instructions. Dang. It's running a lot of instructions, but some of them are doing something wrong. I bet I know what it is. This can't be correct. Can it? Let's take a look at, so I want to look at insns.def. So when we call opt_aset, oh, yeah, this can't be working. Huh. Blah, blah, blah. We call the function and we release it. Do we push the value back onto the stack? So I'm wondering, basically what I'm wondering is if we look at opt_aset, it takes a call data as a parameter. It takes RECV, it takes 3 values. So it pops 3 values off the stack, the receiver, the object, and then the value that we're going to set. And then it pushes another value onto the stack here. And when I look at this, like, I didn't see any pushes onto the stack from the deferred compiler. Oh, okay, we have a push here. All right, so we push a value onto the stack and we push racks onto the stack. So what this means is we're saying, like, whatever the return value is of whatever is in the racks, like, register, that's what we're gonna push onto the stack. And I suspect it's probably wrong. Like, if we look at this, so racks is, according to the C calling convention, oh, what does it mean to have a lower checksum number? Stephanie is asking, what does it mean to have a lower checksum number? I don't know if it means anything. Like, I don't know if lower means anything necessarily, but the numbers need to be the same. So when I run with regular Ruby, it should have the same value as when I run with TenderJIT. And actually, yeah. So the C calling convention essentially says, like, okay, we're going to put the return value of any C calls into the racks register. So in here, TenderJIT is just saying, okay, whatever was in the racks register, that's what we're going to push onto the stack. And that might be wrong, because it's going to be the return. Oh boy, what are you doing, Vim? It's going to be the return value of this function, arbitrary store, and I have no idea what that returns. Yeah, yes, Jeremy, you could be right. I have no idea. Let's see. Let's go to Ruby. Arbitrary store. Yeah, look at this. So this instruction is specifically saying, like, okay, we're going to call arbitrary store and then we're going to return set. So whatever value you passed in for set, that's what is going to get pushed onto the stack. So if you have code that's like, so if you have code that's, well, what happened to my test? Oh, let's go in here. So if you have code like this, it's going to push B onto the stack regardless of the return value of arbitrary store. So this B gets pushed onto the stack. And TenderJIT is pushing the return value of arbitrary store onto the stack. So that's probably wrong. Oh, yeah, that's totally wrong. So it looks like we're probably just pushing like random garbage onto the stack because um, RB area store is returns void. So it's gonna be like whatever happens to be in that register, that's what's gonna get pushed onto the Ruby stack, and we don't want that. That is not good. So let's see. I have no idea how to write a test for this. Let's just fix it in the iSeq compiler and see if it works. Let's see. All right, so we can't just call this function. We need to set the value of rax to param2. So let's see. I've been developing this kind of like DSL for TenderJIT. So you see this like with runtime here. Like, okay. So one thing I have to admit is like when I first started writing this JIT compiler, I wanted to see if it was actually possible. Like, could you do it in Ruby? And the first step I did was essentially like, okay, let's write it, and we'll just essentially write like assembly code in the JIT compiler. So here we're saying like, yes, these are Ruby methods. So these are Ruby methods. It's Ruby, but we're putting together. It looks like assembly language, which I think is kind of interesting. It's like a question. You know, what is Ruby code? Like, what is it? How do you define it? Is this Ruby code? I don't know. Anyway, so I don't want to write assembly language. I really don't want other people to have to write it. So I started putting together this this DSL thing where, oh, okay, fine, be that way, where you can just say like rt.callcfunc, and if we go look at that, where are we? So if we go look at that, we'll see that it actually just like that wraps up all of the assembly code that we have to do for this thing. So, oh, Rodrigo is asking, what do you think about moving each instruction into its own modular class in some refactor afterwards? I saw you had like compile opt something and handle opt something. Yeah, I agree. Like this is definitely a. I mean, I don't know about a particular class for each of them, but yeah, they should have maybe a class. I don't know, but they should be grouped together, and it would be really nice if we just had like the compile time plus the runtime one in one location. I mean, this file is like 2,200 lines long. I really need to refactor it. So, but even though it's a long file, I'm trying to write it in such a way that we can easily refactor it later. Cause yeah, it's a mess. Anyway, so the call cfunc thing wraps up all the assembly that we have to do. And what I'd like to do is eventually put that, like, make an intermediate representation. So have this, instead of like assembling stuff, we'll have it create an IR and then later do a pass across the IR and convert that into whatever target machine that we're going for. And I'm hoping, basically, what I'm really hoping is that we can use this type of API as essentially a testing grounds for something that we can put into YJIT. So the good one. Raddy's asking what architecture are you targeting? Right now it's x86-64. Eventually I want to do ARM too. Anyway, okay. So this is the all getting back to, we need to get something into the rax register. We got to get param2 into the rax register. So let's do like rt dot, I don't know. It got to be a thing. Rt dot maybe return value equals param2. Like there's no way. I might just write a hack to like see if I can get this to work. Let's see. TenderJIT runtime. Does anything in here deal with racks? Let's look. So fix that. Oh, Oh, I already made this. Return value equals. So we'll copy whatever value there is into racks. Okay, cool. So we should be able to do that. And it'll work. I mean, Rainier is asking, okay. I will link to my Vim config in the show note. Check out the show notes. Actually, I don't know if I can do that. I've literally never done show notes, so if I can, I'll put it in there. The Fisk variable name is suspicious. Is it related to Wilson Fisk? Yes. I was just playing, like, I wrote that assembler when I was playing a lot of Spider-Man. I don't know. Didn't mean anything. Is RT emitting assembly? It's not. So it's RT is calling into Fisk, and Fisk will emit the assembly. So RT is, I call it like runtime, because we're doing runtime, we're trying to put together code that for runtime. Because like this return value thing here, I mean, I know we're executing it here, but we're actually writing out machine code that will do it. So RT is essentially wrapping up the assembly. So if we look in here for return value equals, didn't I have a def in here? What file is this? Runtime. Let's look at that. So def return right here. So at runtime, we'll do a mov into the racks register. So let's go back. IC compiler. So return value equals param2. Yeah. Okay. I mean, let's run. Well, first let's run the tests, even though apparently they don't test this case. Or the tests like randomly work, which is not, it's kind of like suboptimal, but all right. Let's try opt-caret again. $4096. I have no idea. I have no idea what's wrong. Samuel's asking, so emitting it directly to memory? Yes. Yes. So Fisk is like, let me pull this up here. Lib TenderJIT. Where the heck is it? I added a thing. I'm trying to find it. Here we go. So we have a JIT buffer. So Fisk provides a thing called a JIT buffer and a JIT buffer class. And all that is Allison says you missed the hash branch. Good point. Yes, I'll fix that. So like it has a JIT buffer class, and if we go look at, let's just look at Fisk, git Fisk lib Fisk helpers. So we have this JIT buffer class, and essentially what it does is, the JIT buffer class is just like a wrapper around the actual JIT buffer, and really what we do is we call mmap JIT here, and essentially that just allocates some memory and marks it as executable, so we can write bytes into that thing and execute it. Okay, let's see, I gotta go in 5. I've got a meeting. The real world calls. So let's do this. Return value param2. Let's do it for hashes too. Yes. I don't know if this is going to fix our problem, but let's see. It's faster. Producing the wrong results faster. Why would this do this? I don't know how, I'm not sure how we can find the error. I guess let's check what this actual checksum is. I don't know. We only got 5 minutes left, so let's look at that. After the compilation is done by the JIT, is it possible to monkey patch a method later? Will it recompile again? If so, how does it detect? Ah, that is a very good question. No, it will not do it. So I'm gonna add that. That's something I'll add in the future. But there's TenderJIT can't tell if you monkey patch something. So let's look at that. It's kind of funny. Um, so if we have like a method that's like, let's just do class foo def lol, have it return like omg. So we'll do this, and we'll compile foo dot in instance method lol. Okay, so if we compile this, actually, in order to make this break, first we'll compile it, then we'll monkey patch it. So we'll do class foo def lol, and then have it return lol. So if we do like p foo.new.lol, this is going to print out lol. But if we do it inside of the JIT, since we compiled it up here, it's actually going to print out the wrong thing. It's going to print out OMG. So let's do that. I'll run it. Oh, they both printed out LOL? That's not good. Why did it work? It shouldn't have worked. Let's do this. Okay. Let's do this. And then monkey patch it. There's got to be a way to break this. That, monkey patch, and then... Oh! No, I better know why this works. Yeah, it's working, and I think I know why. I think it's because we're doing this class.foo here, and that like happens to trigger the JIT to say like, okay, we got to throw away a bunch of code. So I think what we need to do in order to see this break is let's do like foo equals foo.new. Sorry, this is totally a tangent, but I mean, we only got 5 minutes left, so there's no way I'm going to find this opt-caret or this bug in opt-caret in 5 minutes. So, all right, so we'll do foo dot, if we do, let's do foo.lol, JIT, and then let's do like def foo.lol. We'll put a singleton on it. I bet if we do this, it's not going to work. So let's print it. So we should see OMG LOL, but I think what we're going to see is OMG OMG. Okay, I have no idea how this is working. It shouldn't work. Okay. Something jitted needs to call into LL. Ah, yes, thank you, John. You're totally right. Thank you. Oh my gosh. Okay. Call LOL. LOL. Yes, you're totally right. Okay. So now we're going to see the wrong thing. So we should see OMG LOL, and now we're probably going to see OMG OMG. Oh my gosh. Let's call it twice. Let's do that. It still worked. It still worked. I mean, come on. Okay, if I do it in here, let's see what happens. I don't get it. Okay, any chance that instruction is not implemented, so JIT just exits? I don't think so. Let's check. Let's do this. View opcaret. Let's do this. I don't think so. I think there will be no exits, but let's try. Yeah, no exits. Yeah, I don't get it. It should just break. Oh, you know what? No. Because it's checking the class type, and as soon as we set the singleton on it, that changes the underlying class pointer, so the JIT knows to recompile there. But let's switch back to class foo def lol colon lol. This has got to break it. Oh my, okay. And on that note, I am going to end the live stream. All right, thank you all for coming. Hopefully I can figure out this opcaret thing, and then we can do, like, I really want to do that, like, passing in the type thing, pass types down into callee methods. So maybe we can do that next time. I will try to put my Vim configuration into the show notes if I can figure out how to do that. Thank you all so much for coming, and happy Friday!